Hello, everyone, and welcome back. I am Dr. Supradip Das, Assistant Professor at the Department of Design, IIT Guwahati, and this is the 18th lecture of the course Introduction to Toy Design. In today's session, we are exploring toy futurism, how emerging technologies are shaping the future of toys and play. We will begin by understanding the key technologies that will dominate the toy industry, such as IoT, AI, AR, robotics, and additive manufacturing. After establishing these technological foundations, we will examine recently launched and upcoming toys that actively use these technologies. Throughout the lesson, we will critically reflect on how these toys are no longer just play objects, but cultural and psychological tools influencing learning, behavior, and development in future generations. By the end of this lesson, you should be able to clearly identify the technologies driving toy futurism and understand how they transform traditional play into interactive, adaptive experiences. You will also develop the ability to critically analyze futuristic toys, not just in terms of novelty, but in relation to learning, emotional development, ethics, and long-term impact on children. Most importantly, this lesson aims to help you think like designers who can responsibly imagine and design toys for the future, balancing technology with creativity, agency, and human values. Future of toy industry will be majorly dominated by technology. To understand toy futurism, let us first understand technologies that will dominate future. The first one is Internet of Things. Internet of Things, IoT, refers to a network of physical objects, things, embedded with sensors, software, and technologies that connect and exchange data with other devices and systems over the internet. These smart devices, ranging from household appliances to industrial tools, enable automation, remote monitoring, and increased efficiency. The future of IoT in toys is rapidly growing, with the market expected to exceed 37 billion US dollar by 2030, driven by AI-enabled, interactive, and educational or STEM focused connected devices. Key trends include personalized learning, real-time data analytics, and voice-activated AI, which will allow toys to adapt to a child's development. Key focus areas include enhanced security to protect data, immersive personalized play experiences, and integration into smart home ecosystems. The second is augmented reality. Augmented reality, AR technology overlays digital information such as 3D models, images, or text onto the physical world in real time, enhancing the user's environment rather than replacing it. It utilizes cameras, sensors, and displays on smartphones, tablets, or wearables like smart glasses to blend virtual elements with real-world surroundings. Key applications include gaming, retail, and manufacturing. The future of AR in toys lies in creating seamless AI integrated and immersive physical plus digital experiences that blend interactive digital layers with traditional play. By 2050 to 2030, AR toys will evolve beyond simple screen overlays into personalized educational and smart wearable experiences, driven by AI that adapts to a child's learning space and emotions. The third is robotics. Robotics is an interdisciplinary branch of engineering and science, incorporating mechanical, electrical, and computer engineering focused on the design, construction, operation, and use of robots. These programmable machines are designed to automate tasks, replicate human actions, and assist in hazardous or repetitive environments, often using AI for decision making. The future of robotics in toys is rapidly shifting towards AI powered, highly interactive companions that offer personalized learning and emotional social development. By 2025 to 2030, robotic toys will feature advanced voice recognition, modular designs, and lifelike movements, turning toys into adaptive lifelong learning partners. This market is projected to reach over 40 billion US dollar by 2030. The fourth is additive manufacturing. Additive manufacturing, commonly known as 3D printing, is a process that creates three-dimensional objects by depositing materials layer by layer based on digital CAD models. Unlike traditional subtractive manufacturing, additive manufacturing builds parts directly from digital data, enabling complex geometries, lightweight designs, reduced material waste, and rapid prototyping. Additively manufactured toys include items like articulated action figures, fidget toys, and model kits that can be purchased and finished products or printed from digital design files. These toys often feature intricate designs and customizability that are challenging to achieve with traditional manufacturing methods. Most large toy companies are yet to adopt additive manufacturing fully, but this is expected to happen sooner than later. The fifth is artificial intelligence. Artificial intelligence, AI, is a branch of computer science that develops systems capable of performing tasks typically requiring human intelligence, such as learning, reasoning, problem solving, perception, and decision making. It uses algorithms and vast amounts of data to identify patterns, make predictions, and act autonomously. The future of AI in toys is moving toward personalized, interactive, and educational companions, with the market projected to reach over 35 to 40 billion US dollar by 2032. These toys leverage generative AI for adaptive storytelling, voice-based interaction, and real-time learning, transforming from static items into smart devices. However, the rise of AI toys brings significant concerns regarding data privacy, security, and potential impacts on social development. The sixth is interactive toys. Interactive toys are engaging, hands-on playthings that respond to a user's actions, such as touch, voice, or movement through lights, sound, or motion, fostering active learning rather than passive play. They promote critical thinking, cause and effect, understanding, and social skills by mimicking, talking, or playing. often bridging the gap between physical and digital play. The future of interactive toys is rapidly evolving towards AI-driven, personalized experience that blend physical play with digital technology, with the market projected to grow significantly to over 40 billion US dollar by 2031-32. Key trends include AI companions that adapt to a child's personality, augmented reality enhancements, and hybrid digital physical playroom. The seventh is smart toys. Smart toys are interactive, internet connected, or AI powered devices. Example robot, smart dolls, etc. Designed to enhance learning and play. They may feature sensors, microphones, and cameras to respond to user input, often adapting to a child's skill level or behavior. These toys can be controlled via apps, offering STEM skills, coding, and personalized experiences, though they pose potential data privacy risks. The future of smart toys is characterized by a shift towards hyper-personalized AI-driven and connected experiences that bridge physical and digital worlds, with the market projected to grow from around 35 billion US dollar in 2040 to over 380 billion dollar by 2030. Key trends indicate a move towards screen-free, voice-activated companions, hybrid play, and educational STEM-focused tools that adapt to a child's experiences. Now that we got to know about the technologies, let us have a look at some of the recently launched toys that will decide the future of toy industries. Those are not mere toys. These are objects defining culture, behavior, psychology, career growth, and many things for the alpha and beta generations. Robosen is the pinnacle of modern robotic toy companies. Their flagship auto-converting Bumblebee represents just that. It seamlessly converts between two modes, robot and Volkswagen Beetle car. Both modes are operational as well. The car can be driven along and the robot can perform various actions. The toy can be controlled via voice commands and also through an app. It has following pros and cons. Pros: children are introduced to block-based coding for posing the robot and might develop empathy for the lifelike robot. Cons: the fun puzzle aspect of a classic transformer conversion is lost. The natural obedient nature is not natural. This might cause problems in development of social skills. Robosen's auto-converting robots now feature a mini theater play feature, which lets them interact with each other for storytelling. Robosen is also working on a combiner called Devastator. That is 6 robots which will have their own vehicle modes will also be able to combine into one giant robot. Light and sounds in toys are not uncommon, but with Lego's new smart play technology, there is a twist. Lego's smart bricks pack a lot. By reading a smart tile or a symbol on a smart minifigure, the smart brick immediately knows what it is connected to and can produce sounds and lights accordingly. Its motion and color sensors allow it to determine poses and locations and produce appropriate responses. It has following pros and cons. Pros: adds one more layer to building Lego sets, which teaches children how to follow instructions. The sets becoming interactive increases play value. Cons: may reduce exploratory thinking to produce own sound effects. The smart brick also adds excess bulk to any minifigure it attaches to. Lego is positioning this not as a temporary gimmick, but a new chapter in the system in play. The technology aims to bridge the gap for children who move to video games, keeping them in the physical Lego ecosystem longer by providing the responsiveness they expect from digital entertainment. While starting with Star Wars, Lego plans to bring the technology to other popular themes parallel to digital innovation. Lego is investing heavily in R&D for eco-friendly, sustainable materials to replace petroleum-based plastic in future products. Hot Wheels had recently ventured into using AI for their products. With this system in place, AI-assisted remote control cars could be kept moving on track despite curbs. Users could either race with an opponent or an AI-driven cars. Other features include launching virtual hazards to slow down opponents and pits to reload said hazards. It had 3 racing modes: compete with up to 4 friends in championship mode, set a lap record in practice mode, or race off track with the standalone free play mode. It has following pros and cons. Pros: screenless smart toy which encourage strategizing and builds spatial reasoning skills. Cons: playing with the AI opponent might attract introverted children, hindering social skill development. The AI steering gimmick prevents children from learning from natural consequences. Mattel is working with OpenAI to bridge generative AI to age-appropriate Hot Wheels play experiences, with the first products expected to be announced in late 2025 or early 2026. These toys are expected to include interactive AI-driven features. Through partnership like HoloToys, Mattel has explored bringing its physical products to life in 3D animated form using AR, which is being applied to brands like Hot Wheels. These cube has machine-readable patterns on each face, which use augmented reality technology to transform into 3D holograms when viewed through your device's camera. It allows users to interact with and move these 3D models. It can also be used with a VR headset for an immersive experience. The Merge Creator feature also enables users to create their own 3D content, which can then be viewed on the cube. It has following pros and cons. Pros: reduces extraneous cognitive load, enhances spatial intelligence, and supports various kinds of learning styles. Cons: increases screen time, harmful for the eyes. Although the child holds a physical object, they must view it through a tablet or smartphone. This creates a psychological distance between the child and the toy, limiting purely unstructured imaginative play. Following its 2025 launch, Merge Edu plans to release new features for Merge Creator throughout 2026. It allows students to scan real-world objects, upload custom 3D models, and add multimedia labels for storytelling and design thinking. Merge Edu plans to continue alignment with NGSS, Next Generation Science Standards, and international science standards through new editable activity plans for science simulations. Hasbro's Selfies series allowed their customers to literally turn themselves into their favorite characters. Face scans of customers were used to put customized 3D printed headset onto injection molded action figures bodies to deliver these personalized products. The figures were 6-inch scale action figures with multiple points of articulation. Although they were available for people aged 16 years and above, potential impacts on children have been explored in the next slide. It has following pros and cons. Can foster identity and self-worth and encourage children to dream big. Cons: over-focusing on selfie-based toys can shift and focus of play toward the self rather than others. The scanning process was often difficult and could take multiple attempts. For younger children, this unpredictability can lead to frustration and lack of interest before the toy even arrives. Hasbro officially discontinued the Selfie series platform in November 2023. While the company has not announced a direct replacement, the technology for personalized action figures is still active, with alternatives like Funko and smaller custom 3D printing services taking its place. Bubble Pal is an AI-powered companion for plush toys, which leverages the power of LLMs to converse with the user in real time. It uses voice recognition to remember people's names and can personalize experiences based on previous interactions. It has 20 plus customizable character personalities, storytelling capabilities, and parental app for monitoring. It has following pros and cons. Provides emotional companionship, security, and a safe space for emotional expressions. The AI can be programmed to encourage behaviors like drinking water or following bedtime routines. Cons: risk of stunted social growth due to excess digital exposure. The AI may occasionally provide off-topic or nonsensical answers, which can be confusing for a developing mind trying to learn logical concepts through dialogue. Habibi is heavily focused on expanding its AI-powered interactive toy ecosystem following a significant funding rounding in August 2025. The company is building upon the success of its Bubble Pearl device to create a faster, more expensive product matrix with advanced AI features and safety and privacy upgrades. Mario Kart Live Home Circuit is an augmented reality racing game for the Nintendo Switch that blends real-life remote-controlled karts with digital on-screen gameplay. Players use their Switch to control physical Mario or Luigi karts that navigate custom courses created in their homes using provided gates. The game offers grand breaks, time trials, and a mirror mode that reverse the course. It has following pros and cons. Pros: MKL requires children to physically design and build their own courses, fostering creativity, problem solving, and planning. It also encourages social and collaborative play. Cons: immersive AR can make it harder for children to distinguish between virtual elements and real world risks. It is highly engaging, which may lead to technology addiction. Following the release of the Nintendo Switch 2, industry speculation suggests Nintendo is likely to iterate on their toys to life concept, possibly incorporating more advanced high resolution cameras to create immersive in-home MR experience that go beyond the 2D plane of the original home circuit. A 3D pen is practically something out of a fantasy movie. It extrudes heated filament to let you draw and make things out of thin air by depositing layers of materials. Thus, it uses additive manufacturing. It has following pros and cons. Pros: fosters creativity, spatial intelligence, visualization, and enhancement of fine motor skills. Cons: the risk of minor burns from the hot nozzle can create performance anxiety. The smell of melting plastic can be off-putting. 3D pens are increasingly becoming core tools in schools to teach spatial reasoning, engineering, and art. Future developments include dedicated curriculum-based projects kit such as engine and robotics kit that allow students to draw functional mechanical parts. Future pens are expected to feature self-correcting capabilities and AI-driven systems that auto-adjust speed and temperature based on the user's movement. As we look toward the future of toys, it becomes clear that toys are no longer just objects of play. They are interfaces between imagination, technology, culture, and values. From AI-enabled companions to smart toys, the toys of tomorrow will shape how children learn, relate, and see the world differently. Toy futurism invites designers, educators, and policymakers to think beyond novelty and efficiency, and to ask deeper questions about responsibility, inclusivity, ethics, and cultural continuity. The future of play is not only about what children play with, but what kind of futures those toys quietly prepare them for. Think for a while. If a toy is a child's first designed interaction with the world, what kind of world are we designing through the toys of the future? See you in the next lecture. Have fun with tech toys.